with just, again, a quick review of some things on solving inequalities. Again, a lot of it's like equations. A lot of it is, but it's just not exactly the same. So we're still, just like we were in solving an equation, we're going to isolate. We're going to work on getting the variable by itself. Some of you, I'm sure, and I've seen this on other work where we've done equations, can snap off the steps in your head and you're just going to go ding, ding, ding. You're going to be done. Cool. If not, because typically, especially when we do notes, I like to show everything because that way if you are using it later for something else, you actually know where the values are coming from. So if my job is to isolate the variable, whatever's not with the variable needs to go bye-bye. And we just keep doing opposites of everything. So we kind of go oppo here. We make sure that we're getting everything good. We get that set. Straight up like solving an equation, except there's an arrow. That's the other thing. Make sure the arrow is not flipping around when it shouldn't be. And so like we were talking about when we were graphing these the other day, greater than, we can kind of arrow follow when x is on the left because greater than means the numbers are getting bigger, so it's going to the right starting at 10. And again, when we get here, if it's just greater than, because just a quick reminder, if it's just less than or greater than, we're going open circle to say, hey, everything up to that number, but that number doesn't count. Whereas if it's the or equal to, we're going to have that closed dot. So it just kind of lets us see how that's going to work. But the one main thing to be careful of is that, and I'm going to change the wording here a little bit. If you multiply or divide, we're going to put a little add in here. Both sides by a negative, it reverses or it flips the inequality arrow. I like to put in that part of both sides because it doesn't mean that every time you see a negative somewhere, we just start flipping everything. It's something we've got to be doing to both sides to keep that equality. So we're still going to solve this one like we did the one up above. Still want to get the x term by itself. Still want to get the 2 out of there. But here's the situation we're talking about. When I've got to divide both sides by a negative, that's the one where now that arrow goes from pointing to the left to pointing to the right to make sure that I get it right. So whether I'm dividing both sides by a negative, that's one of the good things about showing steps. It kind of triggers your brain to remember that. Or we're multiplying both sides by a negative. So kind of trucking my way along here. I am going to change one thing. So sometimes when that negative's in front, especially when you see a fraction, your brain tells you one of two things. Hey, the negative goes on both, which it doesn't. It only goes on one. And I'm going to save myself a step if I put the negative on the number instead. Because if I keep this as positive 2 and I multiply, I'm still going to have a negative 1. I don't want to do more steps. I want to do less steps. So we get to here. The opposite of dividing by negative 2 is to multiply by negative 2, which will take care of the fraction. Flip the arrow. So just as a little thought process here, not something I'm going to tell you have to do on every one, but this little bubble over here about thinking about it. Okay, why do we have to flip the sign? So let's say I was working on, I'm trying to see which one I want to play with here. Do I want to come back to this? I do. I want to come back to this on something so you can kind of see. Actually, let's do it on this one. So let's say, for instance, okay, so this says x is greater than or equal to -3. What's any number that's greater than or equal to -3?
-3.
Just as I was about to say, but -3, but he's going to give me -3 anyway. Okay, let's go roll with it.
-2.
Let's do this. Okay, so let's say for this one, x is -2. So if I don't flip the arrow and I go ahead and I plug in -2, oh shoot, I did flip the arrow. Oh, I messed up my own thing. Dadgum. I can't do it in that part. I got to do it down here. Oh, fudge sticks. Where that came from, I don't know either. I'm going to do it with one of these because now my brain, my train of thought has completely gone out the window. It's one thing people got to love about watching these later. They're like, this guy, this is raw and unedited. You're not kidding. Okay. I will play that when my brain gets back together here in a minute. Little review. Anytime we see parentheses, we're going to put this in. Now we're back to what we were just doing. Well, that's what I was trying to... Okay. Brain back on from up above. I see what I did now. And I just keep doing my opposites. Again, I'm dividing by a positive, no flippage. No flippage. And as far as your number line goes, when we're looking at this, basically here, I always put my number that I came up with in the middle, and then I'll put a couple numbers that are less and a couple numbers that are greater. I just keep adding one to the right and subtracting one to the left. Arrows eating x greater than. I just get that when I'm good. But the detail stuff is still there. So like for instance here, these are on the same side of the equals. Don't do opposites. Okay, they're not on opposite sides of the inequality. They're both here. -x. And -x is not solved for until we get rid of the negative. Oh. Both sides by a negative. But when you get here, remember, and I always tell people think about money with this so we don't get these backwards. It's like, okay, I owe somebody $7. Now I owe him another $1. Now I owe him another $1. Ooh, but this way, I paid him back $1. Paid him back another $1. Make sure I'm good. We have an or equal to. And we're less than because the arrow's pointing at x saying you are less than me, x. Okay, well, get that done then. And get that set. Now, I am going to mention one other thing. I wasn't gonna, but I think this is good, especially for a class like this. When we talk about your solution set, okay? So there's this thing called interval notation. It's kind of an algebraic way of telling somebody what the graph answer is without them seeing it. And so x is greater than 6. We're always going to do interval notation on your graph from left to right. So what I would do is, I'd say, okay, so here's the left point of my graph. I start at 6. I'm going to put a parenthesis on that. And you're like, okay, so now what are you doing? So if it's just greater than or less than, we're going to use parentheses. If it's or equal to, we're going to use brackets because I can't really use a circle or a closed circle. That wouldn't look right when I'm doing this. And so here I get this. Now here's the part. I'm going to see if some of you are way on top of it here. How do I signify the arrow? Nice. The arrow goes forever to the right to positive infinity because that number line's never going to end. That arrow just goes to any number you could think of as it gets bigger and bigger. And so that's going to work, bless you, that's going to work the same way.
And infinity always has parentheses.
That's right, because it doesn't have a definitive endpoint. Nice, okay. I like that add-in because that's really good. That's like better than I was even thinking. So as we do this, now this time, again, we're going from left to right. The arrow is starting like this graph, but the numbers are getting more and more negative towards negative infinity. So I'm starting with negative infinity when my arrow goes left with a parenthesis, as Caden just said, because it doesn't have an endpoint. And as we come to the right, it ends at 7, but that closed-in circle means we want to include that value. And so if we're asked for interval notation, that's something that we can do with that to make sure.
Shouldn't it be negative?
Oh my gosh. Hardly needed more sleep last night. Definitely needed more sleep. I'm already like 3 boo-boos in and we're not even off the first page. What the heck? Thank you. Hey, we're getting an accurate video if nothing else. So, and we're not going to get real complex with this. I'm not going to go, do I want to go crazy? Am I going to go crazy? I don't think I'm going to go crazy. Nah, I'm not going to go crazy. So here's what we're going to do. So what I'm going to ask of here, I'm going to add a piece into this, but then I'm going to take away from somewhere else. So we're going to make this nice. So we're going to be working on 21 and 22. I want to make sure one thing that I didn't do it. Okay, I didn't. I gave you a day off from the error analysis. So 21 and 22, we're going to add in I'm going to have to add this. Oh, no, I did put that on the answer key. Good job, Dean. So we're going to do the interval notation, too, that we were just talking about on there, just because that comes in handy for a little later down the road. So let's say, ooh. Actually, that's not bad. I thought it was a lot of repetitiveness at first, but I don't think it actually is. There's a lot of mix between positives and negatives and distribute and fractions and all sorts of things like that. So I think this is actually good. So let's do 21 and 22. I've got the key up front. And if you need anything from what we've done the past few days, just see me. I can get you set with that as well. We are not looking